Alright everybody, so in today's video, what we're going to be discussing here uh, is really starting to get into specifically properties and things that we're going to be doing with quadratic equations. Now here where it says the zero factor property, well, that's kind of a fancy way of saying we're going to be factoring quadratic problems in order to be able to see what the solution is. So it's nothing real new. It's stuff that you've been doing from Algebra 1 and in Algebra 2, maybe a little bit in geometry, but it's basically a fancy way of saying solve a quadratic equation by factoring it. Now, the one thing that we are going to be practicing first is a really basic, really kind of a minor skill, is we're going to be determining is an equation a quadratic equation, and what are the values of the coefficients for A, B, and C. Now here, this part at the bottom where it says where A, B, and C are an element of real numbers and A can't equal 0, that is kind of a technicality, obviously, because they will try to throw you off a little bit here and there, but primarily what we're going to be looking at, everything's going to be real numbers, and we're basically going to be determining is it quadratic or is it not, and if it is quadratic, what are the coefficients for the A, B, and C values. Now here, make sure you get all this stuff copied down in your notes, or at least make sure you read it over to refresh yourselves. One thing that we do need to do in order to be able to not so much determine if it's quadratic, but definitely to determine what the A, B, and C values are going to be, is we have to put it in standard form, meaning the A, B, and C terms all need to be on one side of the equal sign and it's equal to 0. And we'll just do that with our normal opposite operations. Simplify everything as much as you can. Get rid of any parentheses that you might have. And well, this third part here, make sure it's in descending order. That's not 100% necessary. We'll go ahead and do it, but most of us are able to see what the largest exponent is, what the next largest exponent is. So we'll talk about that here a little bit more in a second, but that's out of these things here, that one's probably the most negotiable. So taking a look at these examples that we have here, we're trying to determine, first of all, are they quadratic? Now, one thing that let's throw out a little bit of vocabulary here. Let's talk about degree. Really, all of the things that we see here, these are things that we would refer to in mathematics as a polynomial. The degree of the polynomial is the largest value of the exponent. Now, if the term degree is new to you, it's not going to stay that way for long. We are going to be doing quite a bit of work with polynomials and its associated vocabulary. So here, looking at this one kind of in the top left, 3 over 2x squared minus 2x plus 5 is equal to 0, is it quadratic? In order for a function or an equation to be a quadratic function, the largest degree, the largest or the degree of the function, the degree of the equation, the largest exponent must be a 2. So if something is quadratic, the degree must equal 2. It cannot be larger than that. So here, the largest exponent is a 2, so I would say absolutely, yes, this is a quadratic equation because the largest exponent is a 2. So that asks us, okay, what are the A, B, and C terms in there? Well, this one is already written in standard form where the largest exponent is written first, so the A term is 3 over 2. The next term, the next largest exponent would be the middle term, the minus 2x, The coefficient there on the b term is -2, and c, the constant value, is a 5. And that's pretty much it. Now here, the one on the top right, let's go ahead and write it in its proper order. 7x cubed plus x squared minus 2 is equal to 0. So this is the way it would be written in standard form, where the largest exponent is written first and then in descending order from there. Because this largest exponent, the degree of the equation, is a 3, this is not quadratic. This would actually be cubic. Cubic, can't spell. So it's not quadratic. And since it's not quadratic, we don't have to determine what the a, b, and c values are. So the degree of this one is 3, and so that's why we would say it's not a quadratic equation. Pardon me. Here on the lower left, 3x plus 4. Most of us that have taken Algebra 1 are going to be able to recognize this quite quickly, that this is simply a linear equation. The largest exponent of the problem is a 1, so the degree is 1. It's a first degree polynomial, and so we'd say no, this is not quadratic. It is a linear equation. So again, we're not bothering ourselves to determine what the a, b, and c values of the equation are. Now here again, let's go ahead and put it in standard form. Most of us are probably going to see that really we don't need to put it in standard form, but we'll go ahead and do it anyway. So I'm going to take the 4x and move it over through subtraction, and it's going to give me minus 4x here and minus 3 to be equal to 0. So it's in standard form now. The degree, the largest exponent, is 2. So that means, yes, it very much is a quadratic equation. And since it's quadratic, the a, b, and c terms for this quadratic equation, the a is the coefficient of the largest exponent, so that would be 5. B is the next largest one, so that would be a -4. And c, the constant term, would be -3. And that's pretty much it as far as determining if something is quadratic or not and what the a, b, and c terms are. Now, as you can imagine, somebody somewhere decided, well, let's make it a little more challenging. Let's see, what are we going to get here? So we have this equation, x plus 3 squared plus x plus 3 plus 4 is equal to 12. Now, what it's going to say is, first of all, determine if it's quadratic. Now, I can tell right away, because inside of the first parenthesis on the left, the one that says x plus 3 squared, this is going to get FOILed out. But because the exponent here is a 2, that's the largest exponent anywhere in the entire problem, this is going to be a quadratic equation. So determining if it's quadratic is going to be relatively easy or not. But determining the a, b, and c values, that means, well, yeah, we are going to have to FOIL everything out, simplify it, and identify what my a, b, and c terms are that way. So let's go ahead and get started doing that. So x plus 3 squared is x plus 3 times x plus 3. Remember, we're expanding the expression. We're not just saying x squared plus 3 squared. We have to actually say x plus 3 times x plus 3. And then here, because the value in front of the parentheses is really just a 1, we can just drop the parentheses and call it x plus 3. And that's going to be plus 4. And at the same time, we can go ahead and move the 12 over through subtraction and say minus 12, and everything is equal to 0. Now you can see the last terms, the 3, the 4, and the -12. We can go ahead and kind of combine those if we want to. I have a tendency to just do all my combining my like terms at the end after I've simplified as much as I could. But if you want to, you're more than welcome to. So here, we can FOIL this out. So x times x is x squared. X times 3 is 3x. And then the inner terms and the last term, so that will give me another 3x plus 9. And then let's just go ahead and say plus the x here. And let's just go ahead and save ourselves a little bit of headache here. The 3 plus the 4, that's 7. 7 minus 12, that's going to give me a negative 5 to be equal to 0. And just keep combining your like terms. So here, as you can see very easily, that's the only x squared term. So clearly we were correct in saying that because the largest exponent in the entire equation at the outset was 2, it must be quadratic. So 3x plus a single x here is going to give me plus 7x, and then the 9 minus the 5 is going to say plus 4. So now it's in standard form, so we've already established, yes, it's quadratic, because, and the reason is that the degree of the equation is equal to 2. And so the a term, the b term, and the c term are simply whatever the coefficients are. So a is 1, because that's the number that's in front of the x squared. B is a positive 7, and the constant term, c, would be a positive 4. And that's pretty much it as far as identifying whether something is quadratic and what the a, b, and c terms are. Here, we'll move to put it in standard form. On the left side, we'll move the 7 over and say x squared minus 7 is equal to 0. So a, b, and c. Well, here, the a term is 1. Here, the b term is missing, so it's 0, and the c term would be negative 7. And the degree on this guy is, again, 2, so that means it's a quadratic equation. And the one on the right, where it says 3.5x squared minus 0.2x is equal to 0, it's already in standard form for us. The degree, again, is a 2, so that means, yes, it is quadratic. And A, B, C identify the various values of the problem. The A term is 3.5, the B term is negative 0.2, and the C term is missing, so that's 0. Now, that was pretty much the easy part. The next part I don't want to say is not easy, but depending on how comfortable you've been with factoring in both Algebra 1 and Algebra 2 is really going to determine if the next part of this stuff is something that is going to be easy for you or a little bit more challenging. Now here, the zero factor property, again, like I said at the beginning of the presentation, that's just a fancy way of saying solve it by factoring. So we don't really even need to pay attention to all of this other stuff here because it just sounds confusing, and I don't really want to confuse you guys anymore. A lot of students already have enough of a hard time with factoring, but here, let's do pay attention. Read these through to yourselves because these are going to be some of the skills that we're going to be practicing as it applies to factoring a quadratic equation properly. We absolutely need to make sure for these that it is in standard form. We have to make sure everything is on one side of the equal sign and the other, and it's set equal to 0. Okay, we will factor using greatest common factors. We'll factor here where it says ABCs. That's just where we kind of break it into parentheses like that, where like this is x plus a number, this is x plus a number, and it's all equal to 0. Something like that. And this is where it's called, this is the third step here, that's what calls it the zero factor property. Because essentially we just take each factor, set it equal to 0, and see what we wind up getting when we solve for x. Okay. Here, make sure you kind of read this stuff over. We're going to be talking about it as we go through it. Again, the ABCs thing, I don't know what the ABCs thing is. Those are just the parentheses. Some teachers jokingly will refer to that as the butt cheeks, but those are just parentheses where we break apart our factors. Sometimes we'll have to do factoring by grouping, and there are going to be a couple of examples like that here. And I think really the easiest thing is to just kind of get into it don't try to confuse you with a lot of language, and just talk about how we're going to solve by factoring. Now again, the one thing, and this is really, 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 really important. Here where it says warning, please, 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 before you start factoring, make sure the equation is equal to 0. Put it in standard form. I can't tell you how often I've seen students try to factor something when it wasn't in standard form, and if you do that, unfortunately, you're not going to wind up with the correct answer. So here is a quadratic equation. Z squared minus 10z is equal to negative 21. So it's not in standard form, so that's the first thing we better do is put it in standard form. So z squared minus 10z, and then move the 21 over, so that would be plus 21 to be equal to 0. Now at this point, this is where we're going to kind of factor it, set it, break it apart, and see if we FOILed it back out, what would give us the z squared minus 10z plus 21. Now, most of the time, students don't really have too much of an issue with problems like this, as long as the number that's in front of that z squared in this case is 1. Once that becomes a 2 or 3 or something bigger, that's when things start to get a little crazy when it comes to factoring for a lot of students. But most of us are going to see, okay, well, I'm going to need a z here, I'm going to need a z here. And because the term in the middle is a negative and the term on the end is a positive, that really tells you that both of these have to be negative. Because when I add everything together, they need to equal a negative number. And when I multiply the last terms together, it needs to equal a positive number. So the negative times negative has to equal positive. So the factors of 21 that could add up to be a 10 are a 7 and a 3. And real quick, if you want to, just pause the video and FOIL it back out. Make sure that it does give you z squared minus 10z plus 21. And just confirm, just double check yourself real quick. Now these are the two factors. This is a factor, and this is also a factor. A factor is essentially something that is going to be multiplied to something else using your variable. So we have one expression multiplied to another expression. They both contain the variable. That's how we identify it to be a factor. So now that I know what the factors are, to solve the equation, we set each factor equal to 0. And I'm wanting to write x when I should be writing a z. So let's clear that up. So I'm going to set this factor, z minus 7, to be equal to 0. And I'm going to set the other factor, z minus 3, to be equal to 0. So here, if I solve for z, I get a positive 7. Here, if I solve for z, I get a positive 3. And those would be the solutions to the quadratic equation. And they're very easy to check. You can certainly substitute both of the values back in for z and double check that they do give you a negative 21 when you simplify everything. So moving on here, this one looks a little bit different. It's already in standard form for us. The thing is that we're missing the c term, and that might be, this one looks a little bit different. So when the way things look change, a lot of students have a tendency to question themselves. Well, don't question yourself. Identify, well, what do they have in common? The term on the left, 6q squared, and the term on the right, the negative 18q, they both have something in common. They both have a 6 in common, and they both have a q in common. Those would be the greatest common factors between both of the terms. So what that means is I could factor out a 6q, and I would be left with a 3q. Oops, nope, not even a 3q. What am I doing? I'm thinking about the other factor. I'm getting ahead of myself. Okay. If I factor out the 6q from the first term, all I'll be left with is a single q. If I factor out a 6q from the other term, the negative 18, I'm going to be left with just a 3, and that's equal to 0. Now, again, what I said was a factor was something that is multiplied to something else using the variable. So the variable in this case is q, so this 6q, that is a factor. This q minus 3, that's a factor. So we have two factors, and it kind of makes sense. Since we have two factors, since the degree is a 2, I should have two factors, because the degree tells you how many solutions there should be. So set each factor equal to 0, and solve. Here, if I divide both sides by 6, 6 divided by 6 is 1, so I have 1q. 0 divided by 6, however, is 0, so that's one solution. And here, just move the 3 to the right through addition, and I get q is also equal to 3 as the second solution. So there's an example of what to do when you have to factor something. Okay, here is a third way that we could expect to see a quadratic problem. Now, this one I'm going to actually solve two different ways. Let's go ahead and put it in standard form, the way that it told us to do in our instructions. So I'm going to say b squared, and I'm going to move the 12 over through subtraction. I'm going to say minus 4 is equal to 0. Now, this one may be a little tricky for some of us to recognize from Algebra 2. This is the difference of two squares, meaning that the b term, whatever it is, it's squared, and the 4 itself is 2 squared. So this one is going to be a little bit difficult for some students to see, simply because it's missing that b term, and most of us, it's been a while maybe since we've had to do something like this, so it might not just jump out at you the way it does some other people. So since the factor here is negative, and there's no b term at all, that tells you that one of these has to be positive and one of these has to be negative. So b and b, those are the factors of b squared. So the number that I could multiply together to give me that 4, the difference of the two squares would be a 2 here and a 2 here. And again, please, if you need to, pause the video, FOIL that back out, just to prove to yourselves that these two factors will indeed give you b squared minus 4. So set each factor equal to 0 and solve. So here, move the 2 over and I get negative 2. Here, move the 2 over and I get a positive 2. Now this one is a little counterintuitive. Some students are going to have a tendency to try factoring it simply because that's what we've been doing with the previous examples, and because, well, that's kind of what the instructions said to do. Now let's take a look at this in a slightly different perspective. B squared plus 8 is equal to 12. If we just tried solving this like normal, we don't have to solve this one by factoring because there's no b term. It's really easy to do. So if I move this 8 from the left side to the right side, I'm going to get a 4 here. So I'm left with b squared is equal to 4. And if I just said solve it without factoring, we would at this point take the square root of both sides, and that's how I would also get a positive and negative 2 for the solutions that way. Either approach would be perfectly acceptable as far as I'm concerned. One said the instructions do kind of say solve by factoring, so maybe the one on the left in red is really what you should do, but mathematically speaking, both of them are sound, both produce the same answers, so I would be quite happy with either approach as long as you got the right answer. Now here, this is a little bit of a tricky one, okay, and I guarantee you that you are going to see more problems kind of like this, and not to panic when you do. It's very easy to make a mistake with something like this unless you're really aware of what you're looking for. Here, this one has a degree of 3. This polynomial, this equation, is a third degree. That means that there should be 3 answers when we're all said and done. Now the thing is that, well, we haven't really practiced a lot with factoring. None of the other problems that we've seen have asked us to factor something that wasn't quadratic. Okay, but that's okay. One of the tips that did kind of give us, it says factor by grouping. Okay, if I look at the group on the left, n cubed minus 3n squared, there is something that is common between that group that I can factor out, which would be n squared. I can factor out n squared of the first term and be left with just n. I can factor out n squared of the next term, which would leave me just 3. Okay, so great, no big deal. We factored out one term. Now here in this second group, what they have in common happens to be a 4. Now what I'm going to do, if you notice, this is a negative sign. I'm going to factor out a negative 4. If I factor out negative 4 from the negative 4n, I'll be left with just n. Now this is where we have to pay a little bit of attention. Because I factor out a negative 4, what would I have to multiply it to in order to get a positive 12? Well, I'd have to multiply it to a negative number. In this case, a negative 3. Now I want you to pay attention. This is where some students are going to, they can start off the first part right, factor by grouping, but this is where some of us are going to forget and, maybe we get into a rush or we're just not quite paying attention. Now if we notice, here this is one group and here this is another group. What do both groups have in common? Well, they both have an n minus 3 as a factor. So I'm going to factor out an n minus a 3 because for something to be completely factored, everything kind of needs to be multiplied together. And with that minus sign in between, not everything is multiplied together yet. So if I take n minus 3 away from the group on the left, I would be left with just n squared. And if I take away the n minus 3 from the group on the right, I'll be left with just minus 4. And all of that is equal to 0. So now we have what looks like two different factors set equal to 0. So, and everything is kind of multiplied. So now we can start setting things equal to 0 if we want to. Now at this point, the n minus 3, the factor on the left, we're going to just set that equal to 0 and be done with it. This one, the one on the right, the n squared minus 4, we can treat this one of two ways. This, like we saw in the last example, is a difference of two squares. So we can break it up that way, or we can just set n squared minus 4 is equal to 0 and solve by with a square root. So I'm going to just go ahead and do that. I'm going to set the factor here, n minus 3, to be equal to 0. Here, I'm going to say n squared minus 4 is also equal to 0. Move the 3 over, and I get n is equal to positive 3. Here, if I move the n over, I get n squared is equal to a positive 4. If I take the square root of both sides, I will get a positive and a negative 2 as my answer, which a positive 2 is one answer, a negative 2 is a second answer, and this 3 would be the third answer to say, well, I have to have 3 solutions if the degree of the equation is 3. Okay, and we're almost done, not quite done. I know this one's probably starting to run a little bit long, but there's a lot of different ways they're going to check to see how are you trying to solve these things. Now here, the d on the right of the parentheses, that's just going to be distributed into the parentheses. So I'll get d squared minus 10d. And at the same time, I'm going to move that 6 over from the right side to the left side to give me plus 16 equals 0. So now it's in standard form. And again, most of us at this point are going to be able to recognize, well, let's put our parentheses here. And I know I'm going to have a d here. I know I'm going to have a d here. Because the middle term is negative and the last term is positive, that really tells me that this and this both have to be negative, because when I multiply those last terms together, they need to make a positive value. So the factors of 16 that could be added together to give me a 10 are just going to be an 8 and a 2. And at this point, all we need to do is set each factor equal to 0. And here I get d to be equal to a positive 8 and a positive 2. All right, guys, we're getting there, I swear. There's only two more to go. This one and one more. Okay? And I really just want to make sure I work them out, and so that way any of the ones that you see that are similar to it, you have something to refer to that that you can use as a model to work out that new problem. Now here, what's interesting, this is one of the ones that's going to cause students a problem. And it's really because on the right side we have that 20. This is not in standard form, and we can't set, it looks like it's already factored for us, but it's really not. We really need to kind of put it in standard form and then factor it. And unfortunately, it's going to give us a little bit of extra work. So we're going to FOIL the expressions on the on the left side. So g squared, and then here I'm going to get minus 2g plus 17g minus 34 to be equal to 20. Now these like terms will combine, and I'll get g squared plus 15g, and if I move the 20 from the right side over to the left side, I'll get minus 54 to be equal to 0. Now it's in standard form. Now we're okay to factor it, and whatever those factors are, that's what we set equal to 0. If we don't get it to this point first, we're not going to get the right answer. It has to be in standard form where the equation is equal to 0. So here, put my parentheses. This is a g, this is a g. Now here, because this is negative and this is positive, that really tells me that one of these is positive and one of these is negative. Because when I multiply them together, I have to have opposite signs in order to get a negative sign for that third term. So the two factors of 54 that could combine through addition to give me a positive 15 are going to be a positive 18 and a negative 3. So they're the two factors that we need to set equal to 0. Minus 3 is equal to 0. And so here I get g to be a negative 18, and here I get g to be a positive 3. But unfortunately in this case, we have to FOIL out the factors that were given to us, put it in standard form, make sure everything is equal to 0 before we try factoring it ourselves to see what the solutions are going to be. All right, I think I lied to you. There's one more after this one. So here, this one is going to be, oh no, this is the first equation where we see something where a is larger than 1. Now it's already in standard form for us, which is nice, but sometimes having that a term to be larger than 1 can really up the difficulty of factoring. Now I'm going to show you a trick when we get to it about how you work those types of problems that'll work each and every time and take away some of the pain of trying to factor a quadratic equation where that first term is not 1. Now the nice thing about this particular one is, if you notice, 3 is a factor of the 12 and a factor of the 36. So I'm going to factor out a 3 from the whole problem. Okay, so if I factor out 3 from the 12, I'm going to get 4z. If I factor out the 3 from the 36, I'm going to get a positive 12 to be equal to 0. Now, inside of the parentheses here, we will go ahead and factor that. So I'll have a z here, I have a z here, and the two signs that we have are both positive, so that's positive and that's positive. Okay, the two factors of, oh, and I am so sorry. I don't want to have to stop the whole video to rewind it, but I do make mistakes on occasion, and this is one of them. Okay, my mistake is with those signs, because I was thinking about it. I was like, oh, hey, there's a problem there. Because I factored out a negative number, let's think about it. If I factored out a negative number, let's go back. If I distribute it back in, this has to be a negative in order to give me a positive here, and this also has to be a negative in order to give me a positive here. So that's the mistake that I made. Sorry, but hey, it happens sometimes, and we only really learn from our mistakes. So we're still going to come back here. So this is still a z. This is still a z. Now, because this last term is a negative number, one of these has to be positive, one of these has to be negative. So that way, when I multiply them together, I'll get a negative number here. So the factors of 12 that could combine in such a way that would give me a negative 4 would be a negative 6 and a positive 2. And again, just double check me, pause the video real quick if you want to FOIL that guy back out and make sure it gives you the z squared minus 4z minus 12. Okay, but I'm pretty sure that we're okay. Now, at this point, everything is multiplied together. Now, the thing that might confuse some students is the negative 3 on the outside, on that left. The only factors that are true proper factors is this and this. And the reason why those are the proper factors is because those are the factors, those are the things that actually contain the variable that we're solving for. So those are the only things that we're going to set equal to 0. And so here I get z is equal to negative 2, z is equal to a positive 6. Because the degree is a 2, there should only be 2 solutions. Some students are going to set that negative 3 equal to 0 and try and solve for negative 3 even though there's no variable attached with it. All right, finally, last one. Sorry this one seems to be taking so long. So here we're going to say plus 3v squared in order to put it in standard form. Okay, so that's going to give me 0 to be equal to 3v squared minus v minus 2. It doesn't matter if the 0 is on the left side or the right side, as long as whatever we have is equal to 0. Now we can factor this one. Now, this is the first one where 3, or where that a term is larger than 1. Now, I did mention a trick, and I'm going to save that for a future video when we're really talking about factoring, where we have to do that repeatedly. I don't want to give you any more unnecessary information right here, but so here, when we factor this one, I'm going to get a 3v here and a v here. Now again, because this is negative, I have to have something positive and something negative. And here, I already did the trial and error work for you, so this is going to be a positive 2 and a negative 1. The nice thing is that the a and the c term are both prime numbers, so it makes it a little easier to factor. So now that we have the problem factored, 3v plus 2, well, we don't really need that here because we're setting each factor equal to 0. V minus 1 is equal to 0. So here I'm going to get 3v is equal to negative 2, so v is equal to negative 2/3, which is okay, fraction is no problem, and v is equal to a positive 1. Okay, I really apologize. I know that one's a pretty long video, but there's a lot of things when it comes to factoring. Every time I talk to an Algebra 2 teacher, one of the things that that they primarily are concerned about is their factoring unit. Anytime we're factoring, that's a big skill for you guys. So again, maybe you want to pause this one and take a break at some point. But anyway, take care, and we'll see you in class soon.